In this video, we'll be considering the risk matrix. The learning objectives for this video lecture are to enable you to identify and define consequence ratings for risk matrix, identify and define the likelihood ratings, and then to develop a rational coloring scheme for risk matrix. This all begins with the purpose of the matrix. Why are you doing this risk assessment? Why are you using this tool? What question are you trying to answer? That starts with this familiar equation: risk is equal to a consequence times a probability. You begin by first taking your group of risks and defining the consequence categories for them. Once you've done that, then you can define the probability categories for the group of risk. Risk assessment frequently is best to begin by identifying the consequences of interest. Those consequences will depend very much on the question that you're trying to answer. But once you've identified the consequences of interest, then you need to specify consequence ranges. Then you'll have to define them. Let's take an example. Here are some potential kinds of consequences that you might be interested in: safety, environmental, or economic consequences. Then we need consequence categories. You would identify a catastrophic safety consequence or a serious safety consequence. So for as many categories as you identify, you're going to need good functional definitions. Here's an example. Consequence ratings, once you are beginning to rate the risks or the hazards that you are trying to set priorities for, have to be based on evidence. So you don't take a vote and say, everybody who thinks this is a catastrophic consequence, raise your hand. Neither do you make arguments where you have someone launch a long invective about why they think something is or is not a certain rating. The entire idea behind this, all of the value of the risk matrix, comes from your ability to base your ratings on evidence and not consensus. After you identify the consequence categories and rate the consequences, you're going to need to identify the likelihood ranges and define them as well. So to parallel the consequences you saw before, here are some likelihood ratings. When the time comes to rate the hazards or the risks that you are trying to prioritize, once again, it's critically important that those ratings be based on evidence and not consensus or argumentation. After you've done this, it's time to build a matrix. So we have the consequence categories in the column here, identifying rows, and we have the probability consequences in the row, identifying the columns. After you build a matrix, a color scheme is going to be critically important to identify those risks that are of concern and which must be managed. What you want is for the colors in your risk matrix to behave more or less like numbers. So let me illustrate that simply by putting a 1 on an improbable probability and a 4 on the frequent, a 1 on a negligible consequence, and a 4 on the catastrophic. And then if we complete the simple equation multiplication, we end up with numbers like this. And please keep in mind, these are not objective numbers. These are just illustrative of what you are trying to accomplish when you color a matrix. What we would like is to have similar kinds of risks treated in similar ways. And so here you see a color scheme like this, that it defines relatively low risks as a 1, 2, or a 3, medium risks as 4 through 9, and high risks as 12 through 16. As you look at this, you may readily argue that the low risk could be 1, 2, 3, or 4, and the medium risks could be 6 through 12. And there would be no counter for that. But what we do want to assure is that when you have two risks that are 12s, at least they should have similar colors. All the 6s, all the 4s should be colored in a similar fashion. So when people begin to fill in the colors to reflect their risk preferences, we can run into haphazard kinds of rankings that conflict with the way numbers really behave. So it's impossible to maintain a perfect congruence between quantitative and qualitative rankings, but you want to try to do so as much as is possible. Assignment to a cell in the matrix has to be based on professional judgment of the best available evidence. Consensus is an unacceptable basis for assignment. So once you've created the matrix, you are going to place your hazards or your risks in a cell in the matrix. And the basis for doing that needs to be factual. It needs to be evidence-based. In general, a red cell would be an unacceptable level of risk that must be managed. An amber cell could be considered a tolerable level of risk, but it is one that should be managed if resources are available. And green would be an acceptable level of risk, but one that should be monitored to make sure that it doesn't transition to a higher value. What you want to do is avoid this type of situation, where you try to differentiate each cell in the matrix. There is simply no quantitative or theoretical basis for doing this. There's no objective way to distinguish the cell number 2 versus cell number 3 here. It would be just as easy to flip-flop them. 4, 5, and 6 could also arguably be rearranged. Your district engineer has seen this type of thing before in the mishap risk. Take a look at the risk matrix at the bottom of the slide. Notice the severity categories and the probability categories. You'll also notice that the cells are numbered from 1 to 20, providing a hierarchy for the risks. This is the type of thing that in general is advised against. The risk matrix that you just looked at is used to identify risk managers. Any mishap risk with a value 1 to 5 is considered a high mishap risk category, and it would be handled by the highest ranking officer at an installation. A mishap risk ranked 18 to 20 would be a low mishap risk category, and that would be handled by the person directed. There has been some refinement of thinking on these risk matrices. Tony Cox produced a seminal article, What's Wrong with Risk Matrices, and he argued rather persuasively that these three conditions here, weak consistency, betweenness, and consistent coloring, should at least be followed, and that would lead to 3x3 and 4x4 matrices that look like this. If you want to apply these principles, you could use a matrix, such as we have shown here, to classify the activities as at a recreational lake. Here are some examples. You might use these different activities and try to put each of these into one of these cells. Successfully doing so would enable you to know which activities are in greatest need of risk management. Here are our takeaway points. Risk matrices are evidence-based. A risk matrix is a good way to rate or rank risks qualitatively. It's very easy to abuse the risk matrix. Qualitative rankings should behave like quantitative rankings.